And this
Wait,
is...
what?
And then this...
Yeah, that's the one I've done.
Oh, so you've done this.
That's the one.
Have you also
Yeah.
done this one?
Yeah, I've done that one as well. That was hard.
Yep. So...
We can do that one again, but because I haven't done it for a couple of months. But that one was hard.
Okay. And do you... Alright, we'll try this one.
I don't remember. God.
Let's see what we get.
It's like measured in octa. I don't know. Helen believes that the random. Helen believes that the random variable C representing cloud cover from a large data set can be modeled by a discrete uniform distribution. Right, the probability I'm already stuck. Hang on. In my notes. Write down the probability distribution. Oh, there was nothing on like first derivative, like do you know that first principle thing?
Right.
There was nothing on that. That was kind of good. There was no proof, I don't think. In both papers, I don't think there was proof.
That's probably a good thing.
Yeah. Okay, so discrete is when, right, so cloud cover from the, I don't remember the large data set.
Any idea about cloud cover?
Is that measured in octa? Oh, so it's going to be like, is it octa something?
Yep.
So is it going to be like out of, isn't it like out of 8 or something? So, like 1 out of 8.
Eighths, yep.
Yeah. I don't know how many there are though. 12 months. Oh wait, no, wait, how long does it go on for?
Doesn't matter.
So if it's 1/8.
So you could have 1/8 of the sky covered by clouds, that type of thing.
Okay, so then there's 1/8. Eight times, but then you can have like a fully clear sky. So is 1/8 like it's partially covered?
Yes, and you can have a totally clear sky. Yep.
Yeah, so you can have a totally clear sky. Can you also totally covered sky? Can you have a totally clear sky as well?
Yep.
So it's 1/8.
Well,
wait.
How many eighths is it if it's a totally clear sky?
0.
And so, how many parts will there be in total?
9.
Yep.
So 1/8 times 9.
No. So it would be a table of values. Let's draw a table. 9 thingamajigs. What's on the top? Okay. So P, C, C. What goes at the top? Like 1, 2, 3, 4, 5, 6, 7, 8, 9? You can't have 9/8. What did we say you can have? What was the reason that made it 9 parts in total?
I talk about the volume, I just say that distracted. 1/8, 2/8, 3. Oh, but what would you do if it's totally covered? 8 over 8.
8 eighths. There
But
was...
then 0.
Yes. And so that's why.
Okay. 0, 1 over 8. Oh, 0, yeah. Okay, got it. 1, 2, 3, 4, 5, 6, 7, 8. Then 0, that's 8 over 0 would be... Oh wait, no, 0. Is 0 clear sky or is 0 completely covered?
Clear sky.
But it doesn't matter because they're all 1 over 8, aren't they?
Well, are there 8 parts?
But I thought discrete meant they all have to be the same.
Uniform means they have to be the same.
Oh, damn. So 8 over 8.
No. How many parts?
9.
And they're all the same.
So they are all the same then?
Yeah, uniform.
Oh. It says uniform. Oh my god. And then what to do?
Done.
I feel like I didn't answer the question. Write down the probability. Oh. You don't like add it or anything?
Can if you like. You're always going to get 1.
Yeah.
So that's the probability distribution for C. And then part B.
Using this model, find the probability that the cloud cover is less than 50%. So 50% is from 5, I'm guessing. Oh, it's 4 over 8, technically.
So that would be equal to 50%. Is it less than or equal to 50%?
Zero, we said that was completely covered, didn't we? So less than 50%, so that's 1 over 9 plus 1 over 9 plus 1 over 9.
And so what do you get?
3 over...
And what are the ones that are less than 50% cloud cover?
The 6, 7 and 8.
Those are much greater than...
I thought 0 was completely covered.
0 is completely clear.
Oh, 0 is completely clear. Okay, so then 1 over 9, 1 over 9, 1 over 9, up until 4?
Yep.
So it's 1 over 9 plus 1 over 9 plus 1 over 9 plus 1 over 9. 1 over 9 times 4, is that the same thing?
Yep.
Okay. This is actually way too hard for a first question. I would have given that.
So what's the final answer?
Don't know my calculations. 1 over 9 times 4 over 9.
That's it?
Nah, it's got to be add, isn't it?
You did. You added it 4 times.
No, I times it by 4. Hang on. Oh, it's still 4 over 9.
Yeah.
Okay.
Yeah, so the probability that, well, if it's 4 out of 8, then, yeah, if it's 4 octas, then it's exactly 50%. And so less than 50% would be 3, 2, 1, or 0. Okay. And what is that as a decimal?
0.4444.
Okay. Part C.
Comment on the suitability. Oh, Helen used all the data from the large data set for Hearn in 2015. Where can you access this large data set?
Google. Edexcel large data set. This is Hearn 2015.
Well, how many are there?
How many Hearns? There was one in 1983 or something.
No. Wait, is it just one data set and there's like a bunch of information on it?
Yeah, and there's like tabs along the bottom.
I can't find it. That's on it. Is it on the Edexcel website?
Did you Google Edexcel large dataset and click the very first link?
Edexcel large data set, and then I got a bunch of ads there.
Oh.
Classic. Edexcel large data set. Oh, actually. Oh. Very first. Oh, here we go. We don't give them this, do we? Can't memorize it in the night.
So, you wanted that dataset, now you have it. Okay, part C.
Helen used all the data from the large days for Helen in 2015 and found that the proportion of days cloud cover less than 50% was 0.315. Comment on the suitability of Helen's model in the light of a comparison. Suitability of Helen's, as in the model that we just made.
Yep.
Well, we got 0.4. They got 0.315.
Yep.
It's kind of close.
Sorry?
Is it suitable enough?
I'd say
Because it's
no.
kind of... No. How close does it have to be, like, in the 0.3?
Well, if it's not
0.3
equal to
less.
0.4 recurring, so no.
The model is not suitable.
And so D.
Suggest an appropriate refinement to Helen's model. Don't know. Add more. I don't know.
What was her model?
What do you know? That. Helen.
What type of model?
Discrete uniform.
Okay, so what could you how could you change it?
Make it non-uniform.
Boom. Non-uniform distribution.
Which one's non-uniform?
Basically, they're not all the same.
Is binomial non-uniform?
Yeah. Everything's non-uniform except uniform.
Uniform.
Any questions there? Okay. So we can do another stats one, or if you prefer, we can do a mechanics one. It's up to you.
Do another stats one.
Okay.
But like a hard stats one.
Take a look at it. Tell me if this is too easy.
No, that was fine.
Easy enough? Okay. That's mechanics. Let's swap to stats. We're doing this one. Okay. How about this one?
Yeah, let's do this one.
That's right.
Yeah, let's do this one because it's got like f equals 5 and I had no idea how to do that and I've forgotten. Okay. State 2 assumptions Peter needs to make to use her model. Is this the one where it's like that one needs to be large and the other one needs to be less than... Damn it, forgotten. This isn't the one to do with fixed number of trials, is it? This is the other one.
What model is she using?
Binomial.
Yep.
So is binomial the one where it's Fixed number of trials.
Yeah.
Fixed number of trials, only 2 outcomes like success or failure. All the trials are independent.
Yeah. And they only wanted 2. That's good. B.
Use Peter's model to find pH is greater than 4 or equal to 4. How do you get onto? This is not good. Okay, binomial. BCD. Lower is 4. Upper is 10. Number of trials is 10. P is 0.1. I got 0.0128.
And let's open up the mark scheme. I was just writing that out. What was this? Question 3. 0.0128.
Yeah, rounded.
Looks good. C.
Using Peter's. For each child, the random variable f represents the number. For each child, the random variable f represents the number of throws on which the dart first hits the target. Use Peter's assumption about this experiment. Find Pf equals 5. So, first 10 throws. So, we found out that probability of hitting the target was 0.01279 or 124. And this is saying each child the random variable on which the dart first hits the target. When f equals 5. How do you work this out?
I believe it's basically the probability that x is less than or equal to 4 has to be basically x is less than or equal to 4 would be 0. Basically,
Yeah.
in 4 throws or fewer, they get 0 on target, and so 5 or more is left.
And we just worked out that. So we find Px equals. And the rest of that, hang on. So greater is. So the lower is 1 or is lower 0?
You tell me.
I want to say 1.
Do they have to hit the dartboard at least once?
Yeah.
Is
it a lower 0 then?
Oh, I see what you're saying.
Because otherwise there's no really.
So we want 0 for 4 or less.
Yeah, but when you put 4 or less into the calculator, with mine, you do a lower and upper. So for the one that was greater than 4, we did lower was 4, and the upper bound was 10 because it's 10 is the amount of throws it did. Whereas this one, you're doing the opposite. So what's the lower? Yeah, greater is going to be 4. What's the lower? Is it 0 or is it 1?
0.
Yeah.
Because you can hit it 0 times. The one time that you hit it is when it's 5 or more.
Okay, so for Px is less than or greater than 4, we get 0. I lost it. I really lost it. 0.998. I write the whole thing. 36506. That's not rounded.
Okay.
And then that's equal to 0
And so we want, let's see. Oh, I've lost it. X's 4 or less should get you none. No hits. I'm looking it up.
So is it like 1 minus that then?
I think it might be 1 minus that. This is...
Oh, I've got like 1.63 times 10 to the minus 3.
So that's not surprising given that like it does seem like it would be a rare thing. This is question 3.
0.09.
0.0.
They did that to the power of 4.
Some of the probabilities adds up to 1. So they did it. So they did it in a more. They did it, yeah, just like without a calculator type of thing.
They did greater than 4 though, not less than 4.
Information. So they did. What is it?
Oh wait, no, that's B. 0.9 to the 4 times 0.1 equals 0.06561. Okay, because its probability of hitting it is 0.1, so the probability of not hitting it is 0.9, and then they didn't hit it 4 times, so they did 0.9 to the 4.
Sorry, I was looking at the wrong one.
Is that? I'll go back. There, see.
So it's 0.9.
Kind of makes sense, but also never would have got that.
Oh, they hit it on the very 5th one?
Yeah.
I thought it was the 5th or more. Okay, so if they hit it on the 5th one, then yeah, 0.9 4 times and then 0.1. All right. D.
You don't think I can do this. Looks a bit hard. Okay, so Thomas assumes that in this experiment, no child will need more than 10 throws for the dart to tip out first time. Is target like bullseye, or is it just like anywhere on the ball? Not that it's relevant, but
I don't know.
he models P F equals N, okay, as 0.01 plus N minus 1 times A. 0.01 plus N minus 1 times A. So find the value of A. Well, we just worked out for N equals 5. So that one, what was the answer for that? 0.9 to the power of 4 times 0.1 gives us 0.06561. So we just worked out that 0.06561 equals 0.01 plus 5 minus 1, 4a. 0.0 minus 0.01 divided by 4. What was the answer? Because I don't know if it's right.
What'd you get?
I don't want to say because I don't think it's wrong.
0.09 or 0.02?
I've got 0.0139. And why have they got 45? Why have they got 0?
They did the sum. So what did you do? You subbed in the 5 one, was it?
Yeah.
What did you get when? What was the probability? What was the answer for C?
0.0656. Why does that not work? Surely it would work.
We
You
want,
just
so this is 0.7, shift equals 0.01. And what was your n?
5.
Yeah. And you got 0.0139?
Yeah.
So Thompson's instrument no child will need more than 10 throws, where alpha is a constant. So the probability that f is some particular thing, some particular number is equal to 0.1. Why did that not work? Because it's a constant. So they did it like this. Okay, so the sum, so alpha is the constant that it's going up in each time.
If it's a constant, that means it doesn't change, does it?
Yeah.
So why did it not work?
So
It's kind of mean if you're asking me.
I don't see that 2 times. Oh, so they did the sum of a series. A quick way of doing it. N over 2. 2 times the first. 0.02. That's D. Distribution with at least 3 correct values. Series. Comes from working out. We're just misunderstanding their thing, is it? Probability that f equals n. So that was that. So that's when is f something like that or less? Is that why? On which they first hit the target. Don't know. Don't know. I'm leaving it. So using Thomas's model, find the probability f equals 5. Ah, so he's just using a different model. That's why. It's just a completely different model. So that's Petta's model, and this is Thomas's model. That's why. So it's like uniform distribution and non-uniform distribution. So Petta is using this model up here. It's binomial, and he's using this model down here. It's this equation. So it's just a different model. All right. So I think the answer to E is 0.0139 or whatever. Nope. Okay. Try Thomas's model. F equals 5.
0.01 plus 4 times 0.2.
And you get a 0.81.
Yeah.
Probability Thomas's model is 0.09.
How would you get the answer to the other one then?
Say it again, sorry?
How would you get the answer to the other one then?
Sorry, it's 0.02
For what?
for alpha. Alpha was 0.02.
0.09.
Yes. So he's just using a different model. That's why.
How would you work out alpha then?
You have to do the sum of the series. So it's basically you add up all the
formula sheet.
Yeah. You basically add up all the probabilities, make it equal to 1, and solve that.
What are the probabilities?
So, let's go this thing. So if you were to do it the long way,
1, if so, it'd be A.
So the probability of the first one is just 0.01. Hang on, am I missing that question? Yeah.
Because n minus 1 is 0, so it'd be 0A. So 0.01
Yeah.
0.01 plus A.
Yeah.
0.01 plus 2A plus 3A, da 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 da. 0.01 plus 9A. Because 10 is a max.
Yeah. So you could do a half first plus last. That one plus last. That's not too bad. So a half n first plus
It's
last.
10.
So it's 10 over 2.
Oh, wait, no. But which question are we on? Oh, by the way, so 10 over 2. 0.01 plus 0.01, that's plus by 9A. So you get 5.
9a. And that's the sum of all of the probabilities. And what do you know about that?
Equals 1.
Yeah.
So 5, 0.01 plus 0.01. 0.02 plus 9A equals 1. So times 5 is 0.1 plus 45A equals 1. 1 minus 0.1 is that divided by 45 equals 0.02. Yeah.
And did it work?
Yeah, 0.02.
And shift equals 1.
Take a picture.
And yeah, 0.02. So I just put it in the solver. Yeah, so they're just using two different models. Okay. And F.
Explain how Peter and Thomas's models differ in describing the probability that a dart hits the target in this experiment. Peter assumes that the probability will be the same each time.
And her one?
They're both random variables.
Okay.
It doesn't really say that either of them are uniform.
So
is the probability the same each time? No. Is the probability the same for Peter? No, Thomas. If Thomas's model has the same constant, does that mean the probability is the same?
I mean, it's increasing by a certain amount every time, isn't it? What was... So it's going up by 0.02 each time, but is that cumulative?
So the probability of... So the more throws that you do, does that mean the probability of hitting it increases?
So I think his is uniform.
Who's Thomas's?
Yeah, because alpha is 0.02, and if it goes up by 0.02 and you take away 0.01, you get 0.01. So the first one would be 0.01. No, it's not uniform.
And increases.
Let's see. Well, the probability that PETA said for 0 would be like 35%. Whereas his is like 0.01.
Where'd you get the... Oh, if you just put 0 in.
Just put 0 in. So maybe that's it. PETA's model assumes the probability of hitting the target is constant.
Yeah, that's what it said.
And transform probably increases with each attempt. Okay.
Yeah.
Grant. Any questions about that?
No.
So they could have worded that better. Like that it's he uses a different distribution or something. Different model. Okay. This is question 4.
Charlie is studying. The time it takes members of his company to travel to the office, stand by the door to the office from 8:40 to 8:50, literally 10 minutes. Wow. And asked workers as they arrive how long their journey was. Stick with stamp sampling method. Opportunity sampling.
Sounds good. Convenience or opportunity sampling, yep. B.
State and briefly describe an alternative method of non-random sampling Charlie could have used to obtain a sample of 40 workers. Non-random. There's stratified, there's quota sampling. So you can work out the age groups. So like separating like 4 age groups and then ask 10 people from each until the quotas are filled up, or the stratified, which is like a more complicated way of describing it.
And yes, you could do systematic sampling.
What's that? Oh, every 10 people.
Something
Or
like
ask every. But isn't that still non-random? No, isn't that still random?
it's definitely not random. If he uses a system.
Walks through the door.
So it kind of doesn't matter which one, so long as you just do it. So B, quota sampling, for example, take 4 people every 10 minutes.
Doesn't it only do it from 8:40 to 8:50?
Sorry?
It says take 4 people every 10 minutes, but only does it for 10 minutes.
4 people, so you just have to do it for longer, I think.
Oh, okay. Or every 2 minutes, ask 4 people, 10 belong to 10.
Yeah, so long as you fully describe it. Let's see.
State the data selection process Taruni used. Taruni decided to ask every member of the coffee takes them to travel. Every member. That's like a census, isn't it?
I think that's a census.
Yeah.
Census.
Yeah. Write down the interquartile range. Oh wait, hang on, which one's the interquartile range? Yeah. So 58 minus 26,
Yeah.
I'll say. So whatever that is. 32.
32. And E.
Calculate the mean and standard deviation. So the mean would be something out of 95. Oh, I can't remember how do you mean.
Odd out of 95.
I don't know. Oh, standard deviation, you just use those and put it into the formula.
So, what is the formula?
Do we need to remember it? I swear we don't.
I think they have something similar, but it doesn't look good.
They've got variance. All you need to do is like square root it, I swear. It's like on the first paper, S1.
Okay, can you make sense of that?
No way. No, I swear they give it to you. Maybe I just give it to you and...
So there's variance.
Bear with, I'm pretty sure they give it to you.
Variance. So they did just give it to you. You just have to make sense of it.
That's not giving it to you, that's something different. That's too harsh. They've already done that. Hang on, I'm looking.
It's as good as it gets.
Standard deviation is square root or variance. That's all they have given. Oh wait, no, here it is.
So that's all. That's it. And
It's
you usually
sum of x squared minus square root. Oh wait, no, it's square root of the sum of x squared minus the sum of x squared over n.
Yep.
So, if I write that down.
And how did you get over n?
Because it says over n.
Where is that?
Page 3.
The one I'm looking at?
No.
Oh, did you get it from your textbook or something?
No. This is Pearson's. Oh, it says standard deviation. Page 4. Top of page 4. It's sum of x squared.
C2?
No, it's literally like page 4, beginning. 2018 mathematical stats and formulae.
The formula booklet.
Yeah, put them in Excel.
Alright, maybe this is a different one or something. Oh, this is 2013. Maybe that's why. Ah, well. Okay.
So it is the sum of x squared over n minus the mean of x squared, all square rooted. So the sum of x squared is is 20. I always get this wrong because I always do something wrong. Like even if I just plot it in, I somehow mess up my calculator. Even in biology. So x squared is 202,294 over n, which is 95, minus the mean squared. Oh, I haven't worked out the mean yet. Whatever the mean is. How do I cut the mean with this? 4133 divided by 95.
Yes.
4133 divided by 95, and that's all squared. So the mean equals 43.5. That's just to answer one of the questions. This equals... I always get this wrong, I don't know what I do wrong. 202,294 over 95 in brackets minus 43.5 squared. What did you get? Because I don't think I'm right.
Why are you making me work so hard? On mark scheme, what you get?
What did you get?
I got the mark scheme. Mu is that? 15.4?
Yeah.
There you go.
For standard deviation.
Yeah.
What was the mean?
It has to be 43.5. If you got that wrong, then God help us all. 43.5.
Yeah.
Okay.
So, was that static state? Given a reason whether you could recommend using the mean and standard deviation or the median interquartile range in covering the question. There's a large standard deviation, so I don't know if that's quite reliable or not.
What's covering the question?
The little button. Just scroll up a bit. As in, no, scroll down, scroll down. Yeah, it's fine. State giving a reason whether you would recommend using the mean standard deviation or the median and interquartile ranges. I'd recommend the median and interquartile ranges because it doesn't take into account of the outliers.
Correct.
Which would say the results.
Yes.
Rana and David both work for the company and both moved house since Taruni collected her data. Rana's journey to work has changed from 75 minutes to 35 minutes. Wow, 75 minutes to work.
I say 2 hours each way.
2 hours on a train.
Yeah, 2 trains, something like that. 2 trains and a bus.
I would have just not gone. David's journey to work has changed from 60 to 33. So 75 to 35, we have decreased. Oh wait, what? Oh, they both decreased. Okay.
Yeah.
Explain with 2 values Taruni must have changed. Explain which 2 values Taruni must have changed and whether each of these values increased or decreased. What? Okay. Standard deviation would No, I'm not going to say that yet. Hang on. Alright, so the upper quartile, that would decrease. Because on average 2 people less are taking longer.
Okay.
Oh wait, shit, no, there's also the range as well. Oh my god, hang on, I don't know which one to go for. One of that side decreases, and I don't know what else.
So 75 to 35. So that would affect the 75. So
oh my god, that's a massive jump. Would that affect the mean? The median.
So from 60 to 33. So the median was 40. The median was 40.
Mm-hmm.
Yes. And so now it went from being above the median to below the median. So it'll affect the median. And then the other one was 75 to 35. And so that will affect the upper quartile.
Yeah, what happens to them there?
They just decrease. But did they increased or decreased? Yes, they both decreased.
Let's check it.
Yeah. So full marks is
It doesn't change. What? Oh, look at the wrong one. Oh wait, no.
G.
The median doesn't change. Why not?
So if you get the full mark, is both Q2 and Q3 will be lower.
Oh, Q2 is the median there.
Yeah.
But it says state the median and upper quartile are the values. Oh, it says do change. Wow, I really can't read. Okay, yeah, okay. So yeah, that's what we said.
That's what we said. Coolios. Let's see if we can get one more. How about this one? Tell me if it's good or not.
Yeah, we should probably do this one. I really don't like this topic.
Okay, sick.
Sick.
Okay, you do it. I'm busy.
I can't do it, that's why I said to do it.
Oh.
Lifetime hours of a battery has a normal distribution with mean of 18 and standard deviation of 4. So Xn is 18, 4. Alice's calculator requires 4 batteries and will stop working when any one of the batteries reaches the end of lifetime. Oh my god, it's so rubbish. Find the probability that a randomly selected will last for longer than 16 hours. So X needs to be greater than 16.
Yeah.
So menu, stats, distance, normal. We're doing cumulative. Lower is 16, greater is whatever. Standard deviation is 4. Oh my god, it's already there. 0.691.
One. Mean. Hang on, I have to put what, mean in my thing, do I? There it is. 0.691. That's 5. A 0.691. B.
Find the probability that a randomly. Oh no, wrong one. At the start of her exams, Alice puts 4 new batteries in her calculator. She has used her calculator for 16 hours, but has another 4 hours of exams to sit. Find the probability that her calculator will not stop working. Will not. Why can't I just say will work? Will not stop working for Alice's remaining exams. Find the will not stop working. Find the probability that her exams. No, that's actually meant. Find the probability that her calculator will still work for Alice's remaining exams. They are so bad at English. Okay, so but I find the probability that it does work. So we've just said 16 hours is 0.691 for greater than 16 hours. Oh, we have to draw it, okay.
Well, you don't have to. But...
but probably better to the median. Oh, the mean is 18. 16 is there, so the rest of that is 0.691. Less than 16 is 0.309. And then we want to see for 4 hours, so 16 is 20 hours. We want to find out probability of 20. So I want to find out. I don't know how to do this, I'm not gonna lie.
So we don't have to do 20 or more. We just have to find the probability between 16 and 20?
Yeah.
Okay.
So we use that other one.
Lower 60 and upper 20?
It's 5 marks, I feel like it's not gonna be that easy.
Yeah, that's true. 0.383. Taking a punt on that. Oh, I was so close. The probability. Oh, that's why. It's given.
What is?
I think that's what it is. It is the probability that it will be 20 or more, given that it's already done 16 hours. So it's not out of 1, it's out of
0.691.
Yeah.
So the probability that it's greater than 20 over 0.691. What is the probability that it's greater than 20? 0.3085. So 0.3085 over that. We'll never have got that in the exam. I'm not on the phone. 0.446. That is if you do 0.3085 over 0.691.
And so 0.446. So 0.446, and it is that to the power of 4.
Why? Because of 4 hours. Oh, because it's greater than 20. Oh no. Okay, whatever. I'll remember that for next time. Hopefully it comes up. Zero point 0.0396.
Yeah. So this thing is the lifetime. So the probability of it being something is actually the probability of it failing in there. So you wanted the probability of failing in here sometime. Yeah, and so it's the probability of it being in here over the probability of that. All right. Crazy time. Let's see.
So we just worked out.
So we worked out the probability that, given that she has done 16 hours, what's the probability she'll be able to do another 4 hours?
So we've worked out from 16 to 20, given 16. And we need to find out that it will die. Why do they say will not stop working? Should the probability that her calculator will continue working for the remainder of her exam is 0.199? Her exam's 4 hours. Isn't that what we just... Oh wait, hang on. Should you replace 2 batteries? I don't want to do this. That's way too hard.
And then D, after her exams, was more than 18 hours. So how would you do D?
State that the null hypothesis is H0 is battery fire, and mean lifetime was equals 19.2. Wait, no. Did you find out what the probability would be for 19.2 hours as the mean?
And do you need...
So it's greater than... so x is greater than 18. So I don't really know which distribution it is. I'm going to say normal.
So I think it's still normal.
Normal cumulative. It's got to be greater than 18, so it's 19 is a lower. The mean is... Standard deviations are the same?
Yeah, it was 19.2.
But the mean is 19.2. So that gives you 0.5199. If it's great, that's a probability of it being greater than...
It's a random sample of 20.
So which one distribution do we use then?
I think you might have to look this up in the table.
Yeah.
19.2. So you could figure out the z-score, but you'd have to look it up in the table, I think.
Damn, that's hard.
So it's binomially distributed.
What did I get? They got 0.089856. So z minus... Oh, okay, hang on, let me try doing it like that.
Sorry. I think you have to recalculate standard deviation though, is that right?
Why has it got 4 root 20?
4 over root 20.
Yeah, H equals mean is 18. H1 is the mean is greater than 18. Damn, this is hard.
The variance is 0.8 because It's 19.2 and 18? No. 19.2 and 20? So the variance is the difference between the sample number and the number of hours. And the standard deviation is the square root of that. Square root of 0.8 and 2 root 5 over 5. But if I put in 4 over root 20, that's the same thing.
Wait, how did you work out the new standard deviation?
Square root of 20 minus 19.2.
Where did you get square root of 20?
So that was the sample size and that was the x.
Square root of sample size minus the x gives you standard deviation.
Looks like it. Well, there you go. So it was mean is 18. Standard deviation is 2 root 5 over 5. And that's what you're putting into your normal distribution.
Okay.
Good times. And you get this, and so it's insufficient evidence. Yep. There you go. What a way to go. How was that for you, Saba?
That was good.
And so, is our last lesson?
Yeah.
Well,
Less I retake.
Sorry?
I was going to say less I retake, but I'm not going to retake this.
Well, it's been a wild ride.
Thanks.
And yeah, hope you let me know how you get on in your maths. And I hope you do great.
Thank you.
Anything else?
Can you send this, like, today?
Yeah, I'll try to send it out.
Yeah, because otherwise it's just kind of gone.
Yeah.
Thank you.
Well, great working with you, Saba, and take care.
Bye. Thank you.
Goodbye.